Hello, and in this video we're going to focus on decoration and placing props on the level. To get started, I'm going to place around some pillars. And to start, I'm going to go back here where I created this copy 2 points and placed all these grids on it. Like I did before, I usually use a blast node to delete what I don't need. So in this case, I'm going to do the same. I'm going to grab one of the blast nodes and I'm going to tweak a bit in what I don't need. In this case, what I will do is, instead of name 0, I'm going to type in 255. What this is resulting is the geometry here of these floors, as you can see here. So again, I want to actually move it from here, so we have more floor tiles. So this is sort of the center of the room. So if the room is big enough, we have like these floor pieces in the middle, and I want to use them to then place some pillars on. So from this blast node, I'm going to use a fuse, then doing the dissolving again of the edges. Then we could resample the geometry, and in this resample I can control how many pillars there will be. So in here right now there are a lot of pillars, so if I would increase this to, for example, 10, you would have a few here and there. What could be useful here is also to enable the resampling by polygon edge, so it keeps a bit more the structure of the input. So increasing or lowering its value can then decide how many we have. So if you put in 5, we will have equally these 5 pieces. If you put in 2, we have a lot of pillars. But in this case, I think I'm going to go with 10, so we don't have that many pillars, but just a few. Then from here, I can already start using an instance. So what I will do is I will go back to the add node and an attribute instance, copy paste them and place them here. So that's already set up. So the add node is going to delete the primitives, and we have then the points ready to go for an instance. Also here, if I would view the information, I see that I don't have any normals. So let's grab a create attribute, and in here I might as well assign a normal just to be sure that information has a normal. So normal is size 3 and leave it at 0, 0, 0. Now this is then the output for my pillar, and since we are here, I'm also going to build a system to then place around some crates around the pillar. And I'm going to do this by using a copy 2 points. I'm going to copy a tube on the points, like this. So each pillar has then a tube around it. Also set the tube into a polygon, so it's actually polygons here. Then I want to assign a normal direction, making sure it's also saved in the point. Then I'm going to scatter this information, and I will create new points based on these tubes. And this is then deciding how much crates there will be around each pillar. So I'm going to, of course, lower this until we have, like, for example, 60 would be okay, maybe even lower. I don't want that many crates, just a few. I will also have other systems to place props. So the normal was important here to have a normal direction, because the scatter copies it automatically. Then using a transform node. So the reason now is the points are not perfectly on the grid, so I'm going to scale them to 0. So they are now flat on the grid. Then we can also fuse them together to be sure. We can also use this fuse that if, for example, points are too close to each other, we can just increase this value and fuse them together, as you can see over here. But in this case it's not needed, so I'm just going to keep it to a value like that. Then from here I want to copy this instancing again, so copy these 3 nodes, and then later I will set up here the path to the correct model, also here as well. And we can use this merge node here to merge everything together. Also make sure you're setting the right path to the right model. You can also put a frame around it, of course. So this is the pillar with props around it. And this has then to be plugged in the instance over here. Next step, I want to create something more complex to create our layout for in rooms. So in here we have our rooms, and I want to use another wave function collapse in each room to calculate what a room will be like. So again, I will be starting from a blast node. And in here, we're going to filter out on what we need. So with the Wangtail decoder, it's very easy to ask the information that you want. So just by looking at the name attribute, we can easily filter out what we need. So here I'm going to fill in name 0. I'm going to copy the name, filter out as well 86 and number 17, which were some of the connection pieces. And I want to delete non-selected. So we have these as a result. So these are all my bigger rooms. Again, we are going to fuse them to make sure they're all connected to each other. And I want to do a loop for each connected piece. So for each connected piece, and in this case we have 6 pieces. So 1, 2, 3, 4, 5, 6 pieces. So we will have 6 different loops. What I want to do here in this loop is, so for each room, so here is one room, I want to set up a new grid. And in this grid is then calculate how my new wave function collapse will be. So in here I'm going to set this to points as well. This will then be my new wave function collapse pattern and so on. Now further from here I'm going to place down a wrangle node. So attribute wrangle. And I'm going to set this to run over details. So it's going to run only once just to get information. And I'm going to start out by making a float. So float, I'm going to call it point distance. This is equal to a channel called point distance as well. And when we press here on this icon, you have now this slider. So we can set a certain value now. Further, I want to get more information. I want to know how large my input is. So I'm going to type in a vector, which will store the size of the room. So I'm going to say get bounding box. In this case, we want the size, and we want to fill in number 0. So this means from the first input of the node. Then I want to use a float, which will return the maximum size. So we can just use the function called max. Then we fill in here the size. So this will return the biggest value in the vector. Then we can say maximum size plus the point distance. Then I'm going to say add output resolution is equal to, and I want to make sure it's an integer. So the max size divided by our point distance. And we can also put here in front a I for integer. So now I have outputted a output resolution. So if I would go over here, I have now 31 here as value. So if I would increase this or lower this, we would increase the number of resolution that we can use in the grid. So I will use this value that I generated here and then to control, for example, the size or the rows and the columns. Further from here, what I also want to export is a float called just size, and this is equal to the maximum size. So now we have the amount of rows and columns, and also here the general size of what this piece has as biggest length. Now I want information from this wrangle node into this grid, and the way I'm going to do this is by creating here a add spare input, and there will be an extra area here, and we can basically drag and drop this node in here, so it's sort of like linked together. You can also see the line. Now in here we can then ask the size. So in here I stored the size, which is 15.735, and I can ask that information. So I'm going to say detail look at -1. -1 is referring to the spare input. So 0 is itself, -1 is spare input. Then look for something called size. and then 0 as index. So this will now return this 15 value. And I can just copy paste this over here. And for the rows and columns, I want to use the output resolution. So row and columns instead of size, I'm going to type in here that output resolution. So right now I have this grid that should be the same size as my input here. And it has been divided nicely into some grids to use in a new wave function collapse. Next step will be then using a match by size, so match size. And in here what I'm going to use is the alignment feature. So it basically is going to automatically align the grid on the floor. So here is my floor, and it automatically then aligns that generated grid here on that place. So as you can see, when I would play around with the slider, we will have a new density in this room. So I'm not going to take too low values because it's going to increase the calculations a lot. So maybe something like 1 to start with, and I can always tweak it afterwards. Now from here, what we also need to do is we need to delete the points that are outside of my original floor. So some points were not in there. I'm going to create a group node, and I'm going to use again the bounding options to then delete pieces that are not in there. So I'm going to use the thicken node, and in here I can do both directions, give it a certain thickness, like maybe 1 or 2, and we can use this here then in the bounding region with points. So make sure it's set to points, and now we have these points selected. And I'm just going to call them in room. So these points are always in the room. What could also be interesting here is to use an extrude node. And in this extrude node, if we play around with the inset, we can sort of like shrink down the shape. So if I would remove output size, we can shrink down this area. So that could be interesting to tweak the values so we don't touch the border anymore. So if I would go back here, I sort of like shrink down so we don't have that border anymore. So that could be interesting if you don't want props to be too close to the wall. Now further from here, I'm going to start with the wave function collapse again. So what I need is this one, where we generate a pattern, and I also need the wave function grid. What we can also do here, instead of an image, we can just start selecting ports. So let's say we're going to use a 15 by 15 grid. And we can, for example, make a selection for prop placement. So what we can do is we can select some points where we want to have some props and press enter. So these are for props. Then we can do another one for some debris or something. So we can just select a few pieces here and there where we would like to have debris. And we also want to then have enemies. So I'm going to again new one, and I want enemies here. Press enter again. So now we have placed down enemies. And we can then use this in our wave function collapse. And after this wave function collapse, I'm going to use the blast node. And we're going to blast away the group that we made so in room and reverse it. So we have the correct points. So now we can calculate this for then every room. So we can use the loop. So this is then my output, and I can see that my points are consistently scattered around these rooms. And to visualize more what's going on, I'm quickly going to grab a color node and place down a random from attribute, use the name function, and I can now see these points. So I can see that everything is working. You can also again here use a copy to points, so you can even visualize it better, like this. And as you can see, we then have that properly set up. So we have placement for enemies. We scattered around some props. If you're not happy with the structure, we can change the wave function collapse or the main end pattern. We can also play around here with the multi-resolution. So this is 1. But if you think it should be lower or it should be higher, we can, for example, change this to 1.5. And then we can see that pieces are going to be bigger. So these are now bigger. So what we did here is sort of like a wave function collapse in another wave function collapse. And you can keep basically doing this until you're happy with the result. So you can take the parts where no props are placed and you can do another wave function collapse on there with a loop and a lower resolution, and then scatter around new things and so on. So let's see how well this is going to work. And what we can do here again is use the blast node and then filter out based on name. So I will say here add name if it would be equal to the props, then delete it. Then we can inverse this. So these are the points where props can be placed. Then I'm going to use another one. These can then be for the debris. So these are pieces for debris, and then we can do another one for the enemies. And then we can assign here then our instances. So looking at it, there might be a lot of enemies for the room I have. So I might gonna lower the enemies number by changing the pattern. So here I just tweak the pattern and we just have new results then. So I want you to keep in mind that it's quite easy to then start changing and get variation or tweak it more to what you like. So like I mentioned, we're going to create some instancing over here. So let's go and grab some of these instances here. So I'm going to grab the 3 nodes again and place them over here, and make sure to always assign the correct path and also a normal, and copy them along. So I'm just going to quickly skip this part where I copy the paths. Something interesting here is, what if we want some variation here in our normal? So if I would grab here my box with the copy to points, I can see that everything, if I would place a prop down, is perfectly aligned along the grid. So they are all facing the same direction. What I can also do is create an attribute random. So place down an attribute random over here, and we can use the normals, for example, to then get random orientations. So in this case, it's not fully working, and that's because we still have an attribute called transform, which sort of has priority in how the copying is going to happen. So let's delete this transform. So attribute delete transform, and I might just promote it over here. So all these points are having a transform being deleted. And now, as you can see, our cubes are now more randomly placed. So if you don't want them to be randomly placed in the y-axis, we can then, for example, here press 0 and 0. And now they are nicely staying on the ground. So if I would play around with the seed, we can see that they are now having different directions. Now I want you to also keep in mind that there are multiple ways of controlling rotation. We also have attributes for rotation, which is, if you type in rot, we will also have here values to add random rotation or orientation. So these will work as well, but they need to have a dimension of 4. So in this case, to keep it just simple, let's just use the normal and use this 0 and 0. So they have just some randomness in there. So these can then be merged, and this is then for my instancing. Now another thing I did not here account is, for example, I'm placing now props, but what if, for example, my pillar is in the way? So in here I have placed down pillars, but they're of course overlapping with my points over here. So I also want to filter out my pillars from this floor grid. And I would like to use here for a node called distance from geometry. So here I have my first input is my own geometry, and then my second input can be the points over here from my pillars, for example. So it will create an attribute called distance, and it will say how far points are from our second input. And I also want to save this into points, and I'm going to use a blast node here. And in this blast node, we can then ask the distance. So if I would open the sprite sheet, look into points, we have now over here called value distance. Let's say add distance. If it would be, for example, smaller than 3, let's see what happens, and also make sure to set this into points. And now you can see that we have cleared the points around the pillars. And this can be very useful. And now we can start including more of these informations. So if there was a door here as well, I want to also delete props around the door so I can actually walk in there. So in my case, I have a lot of bridges and connections, so I want to get that information. So I'm going to copy this blast node over here, and I want to get all the bridges or connection pieces. And I have to delete name 0 here, and then invert the selection. So these are all sort of my bridges or in between connections. And I want to then include this with my pillars. So plug this in over here. And now we also are starting to delete points over here. What can also be useful is that we resample actually my plane, because it's based out of points, and you can see the result here. Because it's looking based on points, so it can be useful to then just resample this. But this is quite a high resampling value, so we can enable here resample by polygon edge, disable maximum length, and use the here maximum segments, and let's set this to 3. So I have deleted all the points that are close to areas where I don't want the player to be blocked. And I'm going to plug this in over here. So this is just to filter out those areas. So this is then a more complex system to have a wave function collapse controlling the layout. So let's place down a frame, and I'm going to test out if this actually is working. So here in Unreal, I rebuilt my scene, and we placed down a lot of props, enemies, debris, and so on. So in this case, I think there might be too much. Like you can see, there's a lot of debris going here. We have a few enemies here and there. I mean, it's looking cool. It's looking nice, but I think maybe it's too much. Maybe also let's play the game, see how that looks. I definitely think we have way too much props. I can see that some props are coming outside here. That's because probably my blueprint is coming a bit out of its size. So I might have to change that as well. I think there is overall too much debris going on, so I might change that. Overall, it gives us a nice layout to work with, and because everything is a blueprint, I can just quickly grab it and place them around. So in this case, the blueprint should be way smaller actually, so it does not take that much size. So I made some changes to what my original pattern was, so I have just less of some props. What I also did is I exposed a seed value from the wave function collapse node. So I'm talking about this value over here, so we can change the room layout. So now I have 3 main seed values that are very interesting. So I can change the overall layout, I can change where the lava is, and I can change then the layout inside the rooms. So if I would play around with this value, I get a new result. So as you see here, I have now a new result, and I can still of course play this as well. And now it's a little bit less busy and a bit more room for the player. So in some cases like here, there are a lot of props stacked on each other, and that is just because my prop itself is too large for the area the point has been calculated for. So that means I have to scale down these props or scale up my grid in Houdini. So overall it works quite nicely. I hope you enjoyed it and thank you for watching.